Okay, let's take a look at chapter two. So the first part of chapter two, we're just looking at some different types of data displays or graphs. So you've probably been seeing a lot of different types of graphs as you've gone through school, bar graphs, circle graphs, etc. So that's kind of what we're looking at. The first one is called a stem and leaf plot, which might sound complicated, but it's actually super, super easy. So a stem and leaf plot is divided, observations are divided by a stem and a leaf. The stem is the like tens place, hundreds place, etc. The leaf is just the final significant digit. So that's the ones place. So if I'm looking at this, this is a stem here. These are all, these are test scores. So these are 2 digits. So the stem is going to be the tens place. Now, if this included 3 digits, it would be the hundreds place. And then the leaf is always going to be the ones place. So your tens and ones, so go back to very, very back to elementary school here. Find the smallest one. So you're starting in the 30s as you're in order, so that's nice. So 33, the tens place is 3, and the ones place is 3. There's your stem, there's your leaf. Now you're going to group them together by the tens place. So here you've got 3 values in the 40s. So they all have the same stem. They're all in the 40s, and then the leaves are different. So you're just going to go 2, 9, and 9. And you are going to repeat digits because we would want to be able to move this back over to the raw data. Then you've got your 50s. They have a stem of 5. And then we have 3, 5, and 5. 60s. So we're going to go from here to here. So you've got a tens place of 6, and then these are in order. So 1, 3, 7, 8, 8, and 9, and 9. Then in the 70s, we've got, let's see, stem of 7. Then you've got 2, 3, 4, and 8. Then you have your 80s. So you've got 8, then 0, 3, and then we have 8, 8, and 8. And then you have your 90s. So we've got 9, and then you have a 90. So 0, 2, 1, 2, 4 94s. So 4 fours here. And then 96. And that's it. Oh, sorry, I wrote the whole thing out. Just the 6, not the 96. That's it. That is your stem and leaf plot. So fairly simple there. An outlier. We're going to look more at outliers, I think, later in this chapter, but an outlier is just going to be an observation that doesn't fit in with the rest of the data. So these are all pretty clustered close together, but let's say I had like an observation here of 0. That might be considered an outlier. And I'll show you guys how to do the actual outlier test later on in this chapter. The next type of graph is a line graph. So this is just reading a line left to right. You're gonna plot the dots and connect the dots. So here you've got, let's see, let me make this a little bit thicker. All right, so restaurant server records his weekly earnings over a 6-week period as shown on the table below. Construct a line graph. So you have your weeks. These are set up on the x-axis. Your earnings are set up on the y-axis. It's always going to give you the x and then the y. So week 1, so you'd line up the 1 with the 6. We're going to make a dot. We're going to line up the 2 with an 8. Right there. 3 with a 4. Right there. 4 and 3. 5 up to 8. And then 6 is going to go all the way up to 10. And then we are going to play connect the dots. So we're going to go back here. We're going to go left to right. And there's your line graph. And that's all we have to do for that. All right, bar graph. So a bar graph consists of bars that are separated from each other, so they are not touching. The bar heights can represent frequency, relative frequency, or percent. It may be oriented vertically or horizontally, and we're typically going to be using this with qualitative data. So here's an example. So we have a prior statistics class was surveyed regarding their pets. The survey results are given below. I'm gonna change here. Okay. Construct a bar graph that shows the frequency of each pet. So you've got the frequency column here, up to 20. Let's go ahead and draw these categories on the bottom. So I've got cat, dog, lizard, snake, fish, and chicken. Might have to extend this a little bit. Okay. So what we're going to do here for cat is I'm going to take this and I'll try to do it this. We're going to go up to 10. All right. So I'm just going to kind of, and I messed up my pen. Hold on a second. Okay, let's try that again. All right, so we're going to go up to 10. And here's my bar. Dog, you've got 19. So I'm going to go up here, 19. And you're just drawing a bar. It should be a straight line, but I cannot draw a straight line on this program. So we're going to make it look like that. Lizard's got 3. Snake, 4. About right there. Fish is 8. Right there. Chicken is 2. All right, now that's not very nice drawings, so I am going to actually take this and I am going to write the numbers. So sometimes they're on there, sometimes they're not, but it's helpful to put the numbers on if you need to. So lizard 3, snake is 4, fish is 8, chicken is 2. Biggest thing about this is that those are not touching because a histogram is a bar graph, but the bars are touching. So if you look at example 2.1, okay, here, this is showing histogram, those bars are touching. So that's the biggest difference there. So here you have a histogram that shows the results of test 2 for 102 statistics students last semester. And it's grouped. So you can kind of look through here and you can see the test results. So like here you have 1 student scored between a 0 and a 9. 0 students were between 10 and 19. 1 student between a 20 and 29. 30 and 39, that looks like 2. 40 and 49 looks like 3. 50 and 59, if I line that up, that looks like 9. 60 and 69 lines up with 18. 70 and 79 lines up with 19. 80 to 89 looks like 26. And then 90 to 100 is going to line up to, looks like 23 to me. 23. So there's your histogram. Okay, I'm going to stop this and make a new video for 2.3 and 2.4.